Alrighty, everyone. We've made it to week 2 of Python. And so we're going to call this day 2. All right, so week 2, day 2 of Python. We missed day 1. We had that day off, and I think it was a good opportunity to catch up on all of our assignments, right? We should have all of week 1's assignments done and wrapped up so that this week, when we hit our assignments, we're doing it all together in unison with our new subject, okay? So the subject of this week, or we'll have more than one, but this is the last piece of the puzzle when it comes to tools that we'll need to create. Well, actually, there's a couple more before I get ahead of myself, but this is the last maybe major tool I'll say that we'll need to connect our app together to make a full stack application. All right. And what types of apps are we making? There's a silly it's not silly, but there's an acronym on here, your schedule, that we're going to be looking at. CRUD. Anyone know what that remembers, or anyone remembers what that stands for? CRUD.
CRUD, create, read, update, and delete.
Yes, CRUD. So we're creating CRUD. Okay, anyone say that word growing up in elementary school, CRUD? That's the word you say when you get in trouble for saying the other word, right? CRAP. Then your teacher gets mad at you. Unless you went to one of the rougher schools like me for a year or two, right? And then you can say almost anything. Uh as long as it's not going to get you that much in trouble. Anyways, we're dealing with databases today, okay? So let's talk about databases. I've made us a slide to get us introduced to databases. Oh, but before we start the slide, let's talk about our analogy, our restaurant analogy for our app. Okay, we've talked about how an application is like a restaurant, how you have the front, the back, and the database. The front, we said, was the area where the guests or the visitors could lounge in. They would be waiting for their food at the tables. They would be greeted by and escorted to a table by a waiter or waitress and given the menu that they can select. They can select their item or their choice. It was my brother's birthday yesterday, so we went to Cheesecake Factory, and I chose the jambalaya pasta. I never had that. It was pretty good, right? So I was seated, and then I had a choice. I had a restaurant, and I pointed to the one I wanted, and he gave me that. And he went to the back to tell the cook my order. All right. Remember, we talked about that yesterday. So up until now, what have we talked about as far as Flask and databases? We've said the the back end. I'm getting ahead of myself. The back end is like the server area. The cooks are taking that request, and then we said that request could be something like into session, right? We're passing that data from the form in the front end to session, and then from session, we're passing it around. Session is like our current order or the time and place that we're using that form data. Okay, so now that we have that form data saved to session, we're able to present it back on the front. We're able to take information from our HTML form and bring it to our Python server through session. Now we can take that session information and bring it back to the front, right? We're able to serve data to the front end. That's what our server.py does. It's the not the server in the sense of our analogy being like our waiter, but our cook, right? Our server is like our cook, and in a way that the cook is taking that backend request and then giving back that information. All right, now we have another part of our analogy, our restaurant analogy. We have the database. The database is where all the frozen food is stored, right? So when the cook needs ingredients that he doesn't have present available to him, the cook needs to go find where that food is stored, right? He's not going to go to the grocery store and go shopping in the middle of an order. He's going to have a a base of food stored somewhere that's cold and organized in a certain way that he can go back and find the food he needs in time to bring it to the front where he's cooking, and then chop it up or whatever, assemble it, and give it back to the front end. Okay, so we're going to be talking about that piece of the puzzle called the database that we're saying is like the maybe like the refrigerator of the restaurant, right? So it's very appropriate that we're cold weather talking about a database, all right? Because we're liking it to a refrigerator where we can store food or data that our server or our cook is going to be grabbing up to give to our front end. Okay, so let's go ahead and dive into this slide I made for us today. Let's take a look, an overview here. I didn't exactly make it the best way, but it's there. Okay, so databases, we're going to take a look into what databases are and go over these slides here. Okay, so let's look at this one here. Let me see if I can zoom in. What is a database? Oh, no, didn't want to. What is a database and what is a data structure? Okay, let's just talk about this first. Like I said in my analogy, a database is a place to store information, okay? So that's mainly what it is. It's a place to, or there we are. A place to store information. Also a place to retrieve information from. Okay, so this is something that we can store and retrieve information from. And so far, we're able to do that already, right? Can we store and retrieve information from an object? Right? Can we do that? Can we add to an object, retrieve information from an object, edit an object, delete something from an object? Yes, right? We can do that. Now we're just compartmentalizing it to the certain area called the database. So all the things that we have been able to do so far, we're now just going to, again, move this to the fridge. We're going to store it somewhere else. We're not going to just have it right there on the server, on the server.py, because then it's available. It's too available. Okay, we want it to be stored somewhere else. And just like there's a variety of storage systems, right? There's different ways to organize stuff. There's different ways databases can work as well, right? And let's talk also about what a data structure is. I think we're going to be pretty familiar with this, because a data structure defines how you store data in a programming language. So data types, they can be like, arrays, objects, strings. A data structure is how that information is stored inside the database, right? The structure of your database, the way that it's organized with those different data bits of information is something we need to know, because there's more than one way. All right, so let's dive in. This is what this slide is about. We have two different types. We have relational and non-relational databases. Okay, so I'm going to give us a quick introduction onto the different types of databases. And this here, even though it has the titles in front of it, is a really good illustration here. So this is a relational database, and this is a non-relational database. A relational database stores everything in what are called rows and columns, right? We know what rows and columns are from front end, right? Or anything that just has vertical and horizontal elements in a table, you would call the vertical columns, just like a Colosseum, right? The Colosseum holds up the top of the roof by the columns, all right? So those are columns. And then we have rows. Rows go horizontal. Okay, so we have rows and columns of data, and we're going to dive deeper into this, but I just wanted to give a quick overview of the difference between that and a non-relational database, which is organized, but just not as organized, as compartmentalized, as I would say, as a relational database. Okay, now I have some illustrations for us to take a look into this. Okay, next. Okay, so let's talk about types of organization methods. Okay, because this has to do with the different types of databases. So the reason why we have two different types, relational and non-relational, is because of the differences in these five, or roughly five different things here: structure, scalability, schema, query language, and use case. Okay. So as I've said, relational databases, which is what, by the way, we're dealing with today when we go into our database, we're dealing with a relational database. That means that we're dealing with rows and columns. Okay, we'll deal with this in a second. So we're dealing with the relational database. On a relational database, it puts things in rows and columns, whereas a non-relational, as I'm saying over and over, doesn't. It doesn't require a fixed schema that is a blueprint for how things should be organized. It says, okay, you want something organized? I'll organize for you. I'll take whatever you call it and I'll put it in here. You don't need to tell me how I need to have it organized. I'll just store it. But a non-relational, which is what we're dealing with today, we have to define the rows and columns. Okay? And these two different types of databases have different types of what's called scalability. Okay, so scalability, anyone know what that means? If I have someone that does, love to build off what your knowledge is. Okay.
Basically, the ability to grow and change as you add or subtract your information that you need to put into it
Yeah,
in a simple
exactly.
way.
Exactly. The bigger your app gets, the higher in scale or size. Think of a scale, right? Holds how much you weigh. The more you weigh, the more your scale has to, go up or down in measurement of weight. So scalability, think increasing in size of your application. The bigger your app gets, that it's going to matter what type of database you use because of the way it's structured. Okay, so relational databases can struggle to scale, well, what we say horizontally due to, well, horizontal scaling. Maybe I shouldn't get into that. Okay, I'll give you the skinny. When apps get too big, a non-relational database is too hard to deal with. Okay, and I'll show you in an illustration why in just a second. I'll give you a personal example with it as well. Okay, so scalability, when it comes to finding information from your database, think of having a giant refrigerator, right? Or even a grocery store. When you go to a grocery store, everything is stored there by like a non now I'm getting mixed up. Like a relational database, okay? You go down an aisle, all the items there are according to the type, and then it says at the top, you find juice in this aisle or crackers and candy in this one, and everything is organized in a nice compact way. And the grocery store can get as big as it wants, and you still won't, I mean, you can get lost, but you will find your way by the way it's organized. Now, has anyone ever been in a store, a large store that wasn't organized? Something that you just kind of walk around, you wander around like a bazaar, right? You're kind of walking around, you're seeing the different items stored along the walls and the aisles and the shelves. And there's no real organizational structure, right? Like when you go to a place where maybe like an art boutique or something, it'll be more like a non-relational database where all the stuff that you're seeing on the walls are not organized in a super organized, categorized way, because there is no real hard and fast way to categorize everything in there. You just kind of have to be in there and look and know what you want, right? So there's a difference in even how stores are organized. You can even think about how a store would be a relational database or a non-relational database, right? Relational means everything's in a nicely packed row and column structure, or is it something that's more just like free-for-all storage, right? Okay, now maybe I won't dive too deep into this because I'm now just giving you guys lots of information. I think it's good to go to the next slide now. Before we come back to some more definitions, I think we need to see an example. So let's go here. Okay, no, I didn't fill in this thing here. Two main differences between relational and non-relational databases. Here is my example. All right. So let's look at a non-relational database here. All right. See this backpack? Anyone have this type of backpack growing up when they went to school? I'll admit it, it was me, okay? This is not a picture of my backpack per se, but if you were to go back in time and find my backpack in the 3rd grade especially, oh, actually all through high school, it looked like this, all right? It was a non-relational database, and it somehow worked for me. I was able to make it work, and I'll tell you why. A non-relational database do not require a predefined schema and do not use SQL for querying data. Okay, we're going to get into what SQL means. I know it's jargon for now. We'll get into that. Instead, they offer flexibility in storing data formats such as key value pairs, wide column stores, graph formats, or document formats. Non-relational databases are designed to handle large volumes of data, and they can excel in scenarios where the data structure is unknown or could change over time. Okay? It's a way of organization. And I know this looks really disorganized, and it is, but let me tell you the benefits of organizing something like this, as opposed to the drawbacks. Okay, obvious drawback is that your backpack just eats your papers the way this thing does, right? It's just going to just destroy anything. But with this type of organization, whenever I would receive a new paper from the teacher, I just put it in the front. I just put it in the front, and everything I knew that it was relative to what I was dealing with, I'd search from the front to back, right? I'd go to the front, and if it was something that I used more often than not, I would keep pulling it up and putting it back to the front. I wouldn't find in there where I would have stored it previously. Anything I need, I go back to the front. And I didn't categorize anything when I organized my backpack. Any new type of paper or assignment, I would just take it in, put it in, right? And most likely, if it was something we were using very often, I was the first to take it out of my classmates who were very organized, but they would have to go into their folders, look into their files, check to see where they would have stored it. I just had to pull it up from the front if it was something we often use. Now, where I had a big drawback is if the instructor asked or the teacher asked for some sort of assignment that had not been mentioned in a while, it would have gotten disorganized with my other classes, my other papers that I would have assignments from. And I'd have to do a deep search and do very intricate searching to find that one little thing, and then I would be thrown off guard. Okay, so that was a drawback. But as long as I didn't keep my backpack super full of paper, I could just look to the front and I'd most likely know where everything was, and organization wasn't a headache. But like I said, I couldn't take too many classes and store too many papers at once because scalability for me was an issue. As soon as I had too many assignments or too many papers in my backpack, I couldn't really use it for organizing anymore. I would get lost and I get too far behind. So I had to do a lot of backpack cleaning every so often, but that was just my way of organizing, and that's the way sometimes you can organize a database, right? And I'll go back to this in a second, the benefits of this as well. Now there's another way to organize, and if you had strict disciplinary parents, and I did, but I didn't do it anyway, all right? You would have organized your information or your homework a little better, right? You would have had your English assignments in your English folder, your algebra assignments in your algebra folder, your biology, and so on and so forth. Everything would have been nicely organized, and in here, in each binder, there would have been tabs as to which day and week each assignment was from, and you would have had all the papers. This is something like a relational database. Okay, this is something like a relational database. Everything here, if you want to know where the biology information is, you go by the key here name biology. So you open up this value and then you can see here where the different assignments are in this related to biology in this particular folder. Okay. Now, the drawbacks for something like this can be what? Well, let's say um, let's say you have your first day of school, right? And you have this huge organization structure, all your folders, all your files, and the first week of school, the teacher tells you pull out assignment. Maybe you don't have your backpack open. You would have to do a little bit more digging in order to get to that specific part in your binder or your folder of where that assignment is. You got to look into the category, go into the file system, dig it out. And there's a surefire method of where it is, but it's not gonna be as fast as, oh, I only have one paper in my backpack anyway, so I'm just gonna look to the front and there it is. Okay. And I don't have to go through the effort using this non-relational database to store. I don't have to go through the effort of looking in where am I going to store this and that. All that takes somewhat of effort that when you scale it up further and further, it becomes more work for the machine. Lastly, all right, what if you get a piece of paper from your school, like we're talking about databases and how backpacks relate to them still. What if you get a piece of paper from one of your classes in school that don't fit any of these categories, right? What if you get an assignment that's not German, biology, algebra 2, or English? Where are you going to put that paper? You have to this system only works if you have the predefined categories, right? Otherwise, you got to find some other place to store miscellaneous papers, right? And so the difference is like everything in a non-relational database is basically miscellaneous, right? So you just give this type of database information. They just say, I'll store whatever you give me. I'll just put it in. It doesn't matter what category it is. It's just going to be its own category. It's going to be front, the next to front, so on and so forth. Okay. So now that I've gone into this and I've admitted my type of organization skills, who here was backpack 1? All right, type in chat if you were backpack 1 in school. Come on, where are you? Am I the only one? Oh, there we are. James Abisai. For shame. Shame on us. Hey, we made it though, right? We're here. We're in the same class as y'all. So all right, now let's see you proud organizers. For all you relational database backpacks, give us a 2 in the chat. Who's a 2? Awesome. We envied you. Yes. And your colored pencils? You put all the plus colored paper. Colored paper. Yes, and now just another personal question. How many of you relational database backpack organized people would just look at the ones right next to you in class and just shake your head in pity and shame, right? How many of you just looked at us like, you guys are just helpless? Well, we don't want to know, okay? We don't want to know. We don't care. We know that we're messy, but it worked for us. And so some people use relational and non-relational databases. Now, again, with any analogy that it doesn't fit perfectly, but can we get the general picture of the differences in styles of database and how they could be beneficial or have their drawbacks? Okay. I need some feedback here, so please answer in the poll how well we're understanding. Okay, fantastic. This is the best feedback I've had so far. So it looks like we're doing good. Okay, So now, I see my hand is raised. I'm gonna lower my own hand. There we are. That was annoying. Okay. So now that we had a taste of what the difference between relational and non-relational databases are, I'm going to explain what ERDs are. Okay, ERDs, and this is what we're going to be working with today. An ERD, as you see here, is called an entity relationship diagram. All right, in MySQL, it is a visual representation of the major entities within a system. So it is a visual representation of basically all the folders and files out in the open and how they relate to one another. Okay, because data can relate to one another. Data diagrams, as you see here, for example, this city has an ID. This one would be the name. I think it could be named better. City name, and then we have a country ID, which is something else, another form of ID. So what we're looking at here, let me see if I can make this image a little bit bigger. See if I can pull it up here. Give me a second. I have this up for us. Okay. All right. Here we are. I have a better example with this image here. Same image, it's just that it's a little bit easier to digest this way. Okay. So look at the way that this data is organized. This is what an ERD is. It's an entity relationship diagram. Okay. And in this instance here, we have one what's called table. And these are the columns in the table. All right. And each column has rows of data in there. And we're going to give a better visual of what this looks like in just a second. But imagine here, I'm saying these are the columns. This is one like the title of the data here. We have the address, and we have the postal code, phone number. This is a local address. And each local address exists within a greater address, right? A city. So each address exists within a city, and a city has its own set of data, the name of the city, and more information and so forth. We won't go into that. But here we also have country. All cities belong into countries, right? So there is a relationship between this data and the way that these tables are stored. And these relationships are the connection between them in this ERD is represented by this little arrow thing here. It's like a connector. It's like an anchor. In this ERD, the anchor is what is our visual representative of the table connections. But what's actually connecting them is this what's called ID here. All right. This city contains a country ID. That is the ID of the country it's in. And so this ID here, it gets from country. A country can have many cities, right? So there will be maybe another city table with its own addresses. But what this represents is all the cities and all the addresses and how they relate. All the cities relate to country. All cities are a part of country. And we're going to get into what types of relationships data can have, but I just want to give you a small preview of what an ERD, it's an entity relationship diagram, which is how the data is stored, how it's stored in our database, what's the relationship between the data, and what are the column titles for each of the data. Okay. And again, this is a little bit, it's getting a little bit more complex. This is getting to the heart of the practical side of the lesson. But I just wanted to give you guys a preview. Okay. All right. Where were we? Let me go back to presenting and then we'll finish this up. Okay. MySQL Workbench. Oh, where were we? Okay. Relational entity relationship diagram in MySQL, a visual representation of the major entities within a system along with their properties and relationships among them. That's what we just said. These diagrams are used in a database to understand how the structure of the data and how it relates to other data in the database. Fantastic. So we should have this understood. So let me take a poll. How well do we understand? Don't worry about the second paragraph. I'll explain what that means in just a second. How well do we understand what roughly an ERD is and what it does and how it works? Oh, where's my poll system? It's disappeared on me again. Okay, it's gone for good. Oh, here it is. Okay. All right. How well do we understand what an ERD is so far? And then we'll finish up here. Almost done. I know this is we're going to go into depth about this. So I know I didn't give the best job explaining this. I just wanted to explain that this is something we're going to be looking into today. ERDs, entity relationship diagrams. And where we're going to be building these ERDs for our database is in a tool called MySQL Workbench. And so this is a workbench. So it's a program that lets us create a visual database so that we can create these ERDs and then it will turn it into code for us. So we have less coding to do with something like a tool like this, right? Where we just make the tables, we connect the tables, and then we say, now make this database, and MySQL will say, okay, based on this diagram here, I'm going to make code for a database, and then I'll give you the code for that. And we'll say, thank you. Because if we didn't have MySQL, we would be having to write what's called SQL queries or SQL code or create our own database. So this is a sort of a shortcut tool that we're going to be glad to take advantage of today. All right, so lastly, let's take a look here. We're gonna go over installation of MySQL Workbench. We're gonna get it configured together as a group, and then we're gonna talk about how to make databases, so the implementation of a database, and get it structured. Okay, and once we get familiar with databases for a couple days, let's look at the calendar here. Once we are doing queries tomorrow, so that means we have the databases already created and we're asking now information from our database, we'll be able to connect our database to our Flask application and then have a way of getting information from the HTML through the server, holding it using session, and then taking that session data and storing it in the last place here, the last base, which is the database, right? That's where the data should live. So then from the database, tomorrow we're going to be pulling from it to bring it back to our server. It's going to bring it back to our front end. So we need to learn how to communicate with the database today. And in order to do that, we're going to have to get some things installed. Okay, so if we pivot over here to the platform, I'm going to go ahead and link this in the chat so we're all in the same place when we do this. And let's see here. We're going to have two different installation, unless you're Johnny, right? You're going to do Mac or PC. All right, I've just linked the Windows, the PC users. The Mac installation should be right there next to it in the platform, so please follow along. I'm going to go with Mac first since I'm a Mac user. Double check here. I don't think it's super necessary, but let's go step by step. Check your system specifications on the Apple icon menu. Click about this Mac. Depending on your system, the appearance may vary. Okay, so just want to double check that your processor is not super dated so that things doesn't crash your computer. Okay. All right, and then it says go to the MySQL community server downloads page for the most recent release and select the Mac OS DMG option. I was thinking this morning about whether I should separate us into groups at this point and have some instructors like, walk through this with the students doing Mac installation versus Windows installation. Is it super necessary to do that? Either of the Tylers or Kyle? I'm not sure if you guys are there, but okay.
It's mostly goes pretty smoothly. I think if anybody has any issues, we can troubleshoot it after. The only
Okay.
Mac is not as smooth as Windows in
Okay.
this one case.
Yeah. And so for Mac users, we're going to have a little bit more trouble installing and getting MySQL Workbench working. I have it working on my Mac, so it is doable. We're going to see my lectures and presentations using a Mac version of MySQL. But there is a little bit of a process to get it going. So let's go to this link here. And then it says, go to your operating system. And so here I am. And then I'm going to look at just like this one here. So you guys get to see what kind of computer I have. I'm going to go here and say about this Mac. You guys can see I didn't do the download last night. So if you guys have some Mac users. So I have here my information that I need to know. And so when I go to this page, I want to check to see that I'm using the correct version. So let me just pull this tab next to this one here. I want to see that I have the correct version. So, okay, this is okay. This looks good. And so there is, I think, two options, right? There is the 64, and it's only a slight difference. So you can choose either one, but I don't think it says anything about select version here on the platform. So I would just leave that as is. And then click the download on these one of these two top ones here. Okay. Then let's say you download it. What's the next screenshot here? Maybe I can just download it again. Okay, I'm gonna click no thanks, just start my download. Okay, here it is. And I'm gonna go through this, but I'm not gonna actually get it installed because I already have it installed. So it's downloading right here at the top right. I just want to finish this little circle. All right, we're good to go. Okay. So once I get it started here, here's what I have. I've opened it up. So let's open up this package. I think it's going to give me trouble because I'm already installed. So I would have to uninstall it for you guys, and I'd rather not do that. I'd rather just hear if you guys have any problems setting up. Now, here's what I want you guys to know for Mac users. It's going to ask you to create a password for your server. Now, the main difference that I would have you guys note between PC and Mac users is that Mac users need 8 characters in this password here. Password needs, right now, we're going to stick to just the word root for PC users. All right, so let's just keep it a base thing. And for Mac users, root. So double root, and then that's it. Okay, so we have root and root. Set that as your password. 8 characters if you are Mac, 4 if you're PC. And let's see what the PC version looks like for a second. Where does it say to set the password root? Okay. Here it is. At this point, when you're installing it on your PC, it's going to ask you to set your password. Again, PC users, you want to just use 4 characters, right? Don't matter if it's weak. Right now, we're not going to worry about hackers going into our database. We just want some fluidity and consistency across all our students right now so that we can not have to deal with what's not necessary at this point. We're just learning how to use a database. It doesn't have to be super secure. Okay, so then again, root for Mac users. When you get to this point on Mac, let's see, let me just, it'll be in the configuration tab when you're installing, right? So here for Mac users, you want to do root, so 8 characters. Okay, and then at that point, you should be almost set up. And so when you're at this point, I think, let's see here. What you want to do is open the system settings or preferences pane to my SQL server with the dolphin icon. So if I go here, I go to system settings and pull that up. And it says, this is where you can start and stop the SQL server, although you may just leave it running. If your server is stopped, go ahead and start it now. Okay, so let me go ahead and find the SQL tab. Here it is at the very bottom. And here we are. Okay. And you can start and stop the server using this big button here, right? Stop SQL server, start SQL server. And you can either choose to have it start up when your computer starts up or not. Okay. I always use SQL these days, so I just prefer it just starts up when my computer starts up. All right. And let's see, I don't know that, is this necessary? Let's see here. Let me just double check. Create a MySQL alias for terminal connection. I don't believe I did this. So I'm not sure that it's so necessary to get working. Oh, well, we can try it. Okay, I might as well do it with you guys now. Okay, if it breaks, then we know what we're doing next lesson. We're gonna fix it. But after we have it set up, I think we're gonna call it quits for this lecture because we're already going past the hour here. And we'll make it a 2-part lecture day today. We're in the next lesson, we're going to deal with ERDs, relational databases, and how data is organized. But right now, I just want to make sure that we all have MySQL up and running. My first day of MySQL, I fell behind, as usual. So I'm going to make sure no one else falls behind. All right, so now I have my terminal running, and here it is. So let's follow the steps. Run below. Okay, check to see if you're using ZHS as your terminal window. This will be the default for Mac. Yes, I'm using ZHS. So there it is. ZSH. Sorry, my dyslexia. And then here we are. Echo, and then export path equals path local. So copy this. And then it says, if you're using bash, not ZSH, replace this with bash profile. Okay, so I'm using ZSH. I'm just going to copy this here. All right, and now let's look at what this command does. Echo. So we'll write to a file. So this means write to a file. And then this is the file path here. So this is the path of where I'm going to write into a file. And then export at the beginning makes the value available to programs that you run from that terminal. So we're gonna make this path available to programs from this terminal. And then we're going to set path to the value of the path variable. So we're giving a variable name here to path. And we're giving it a value that can be interpolated there. And this is the location where the MySQL command that we just installed can be executed. This will append the file. So it's going to augment the file. Add it to the very end there. And then let's see where this is a file that the terminal look. Okay, so this is for making this is specifically for this type of terminal, the ZSH. Double ampersand says we'll run another command. And then the very last command here says it will execute the changes made as made and make them available in the terminal window. Okay, so let's go ahead and paste that in my terminal. Everything looks as should be. I'll press enter. And there, that's it. That's all you need. That's all I needed to do. Okay, now it's saying I should be able to connect to MySQL shell via terminal. Okay, remember, what is a shell? Anyone tell me what a shell is?
You activate your file, your program.
Right, what am I in right now? I just opened up something. This is like the Python shell, right? X equals 5, print X. Now I can view whatever I need. Okay, but if I say, for example, I think it's Control Z. Oh no. How do I exit here? I think it is Control. Where is it? Not just exit, is it? Use exit or Control D. Control D. That's what it is. Okay, so there's a special way to get in and out of your and now I activated my pen without even knowing how to turn it off. Okay, there it is. Whew, I'm giving myself a headache here. Let's start over. New terminal. We're going over what a shell is, and I'm giving an example of what a Python shell is, right? So if I type in the word Python 3, I can type in Python commands, x equals 5, print x. This is my shell. It can read Python. But I can't do x equals 5 on my normal file path explorer here, right? So if I say x equals 5, it's going to say, what do you mean? And if I say print x, it's going to say, I don't know what you mean. What is x? What do you mean print? Right? So it's another language. This thing doesn't speak Python. But if I say Python 3, then I go into the Python shell. So what this is looking to do is connect to the MySQL shell via terminal. So now I should be able to say MySQL SQL dash uroot dash p. And then I should be able to type in my password now, which is root, double root, enter. Now I am in MySQL. All right, so now I'm in MySQL. Now I can start writing what's called SQL queries or SQL code. How do I exit this? That's a good question. Let's type in help to find out. And so now, whenever you're in a terminal here, you can say exit MySQL, same as quit. All right, so let's do that. Type in exit. Now it said goodbye. Good. All right, goodbye. Well, I've just now entered and exited the shell, right? So now I can say, this is the way to enter, type in the password, root. And if I want to exit my shell, well, I know that I'm in because it just looks like this. It looks a little different, my SQL than the arrow. So if I want to exit, then I exit. We're not going to be working much on the shell. We're going to be working on what's called Workbench. All right, so further installation for Mac users. Let's continue. We're to install MySQL Workbench. Go to the download page for the most recent release of MySQL Workbench and click to download. Okay, so let's go here. And then download this one here. Okay, so once you click that, you should be starting the sequence. I'll click it and I'll just say, nope, just start my account. Oracle. I used to pass up that building on the way to work most days. Okay, so now let's click this. All right. Let's open up that file that I just downloaded. MySQL Workbench. Oh no, wait. Did I just open up the wrong one here? No, I think it just went in the wrong order. Let me just check my download. Sorry, I think it just organized itself. Yes, I want to click the MySQL Workbench, not MySQL. So don't make the mistake I was just about to make. Look that you're opening the ones called Workbench here. Okay, and you open that. It should look like this for you Mac users. Okay, and what you want to do then is drag it over, right? You want to drag it over. There. So I already have it there. And I'm going to say, don't do that. Don't copy over what I already have. But if you're doing this for the first time, then you're right? You're doing it over. You're copying it over. Okay, now what's left? Okay, and then you should be able to open it up and then get it working. Now for Windows users, let's see here. I would normally just switch over to my PC I have to my right here and just continue the lecture from there, but I think installation for Windows is going to be a bit easier, so I don't think I need to. Okay, James says it went pretty easy. Now, how about this? If any Windows user has been installing this and just listening to me for the Mac users and wants to ask for help, type 1 in the chat if you're struggling as a Windows users to get MySQL installed and up and running. Okay, no shame in admitting like I said, my first day, I was a PC user. I couldn't get MySQL up and running. I always have issues. Always had issues, no matter what. No matter what job, I always have issues somehow. Something's always pulling me back here. It says I have Mac, but it says for me incompatible non-standard server version connection. Okay, so what I will say for the Mac users, if you are still getting a hang up or if you're getting caught on a snag here trying to get it up and running, what we'll do is have another hands-on tutorial with installing this with Mac users by coming to my room after this lecture. I'll get you guys up to speed. Now, if you're a Windows user and you're not up to speed, please find another instructor. I think all of our instructors here are Windows users, mostly except from me. So yes, find your, and you can find me as well. I have a Windows machine right here next to me. I'll get this up and running with you with our Windows machines together. So there's no excuse. Find us. We have to get this working today in order to continue with all of our assignments and lectures and just the content we're doing today. Okay, so get this installed, get this up and running. MySQL Workbench for Windows and Mac. Okay, once you're in, it should look something like this. Okay, I'm going to pull up mine. I have it here available, so let me just get it up and running. It should, give me a second here. All right, so here is my workbench. Loading. And here we are. This is what mine looks like. Okay, we're going to take a next lecture to dive into how this works, right? Because here is where we can create models for the relationships between databases. We then take these models and create them into databases. Here's where my databases live. I can go in there and see the databases and query them if I enter in through here, which requires my password. So here's what I will enter it. But there's so many different things you can do with this program and different things. I don't want to get us confused because it is easy to get confused with something as simple as this. It can be overwhelming, right? So let's save this for this afternoon lecture. I'm just going to see here what the content is with you guys. We are going to be going over ERDs, or entity relationship structures here with one another. All right, we're going to be creating these together, connecting them, talking about the types of connections that exist, types of relationships that can exist, one-to-one, one-to-many, many-to-many. Diagram, entity relationship. Thank you, Kyle. I missed that D there. All right, so alrighty, everyone. This should be a fairly straightforward day, not something too harsh. As you can see here, when we are in the Python stack and we are finished doing OOP and Flask, the stress level should be going back down to a minimum, just like when we were working Python the first day, right? So our stress level shouldn't be that high. It's going to gradually increase for the next couple days, especially Thursday, Friday. So we want to be ready for Thursday and Friday. Get today wrapped up, squared out, so that Thursday and Friday, when the difficulty rises, we're all there. And then finally putting it all together Monday and Tuesday for the exam on Wednesday. Okay, and that's when we're going to be putting everything, our connections of everything, to the test. So again, we're at the blue stress level. We're at very easygoing. We're going to be just downloading, installing, and then creating some databases, right? Fairly simple. Okay, I want to know where everyone is as far as installing and configuring this thing to make it on your computer. MySQL Workbench. Give me a number here so I know where along the lines you are, how close you are to the finish line. Okay. Looks like you guys are all almost there. So it's looking great today. I'm glad we had our holiday yesterday in case we needed that to catch up. And so we're going to be continuing this afternoon lecture at 2 Mountain Time. I don't think I'm going to push it to 2:30. We're going to be on schedule today. 2 Mountain Time. I'm already, my subconscious is pushing it. At 2 Mountain Time, we are going to meet and we're going to finish up our introduction to databases. We're going to talk about ERDs. All right. So the end of the day assignment for today is to create an ARD model, right? So let's see if you guys can read up ahead. That's the goal, to read up ahead once you have this installed and see if you can create your own ERD model. This one is going to be for books. So this is the end of day assignment. And so let's try to get here and work on this before next lecture so that we can have some decent questions in case we run into any snags, like I said. If we have any problems, we can ask during the lecture. Better be informed in case we learn something new or have a solution to something that we need fixed. Okay, so let's go ahead and wrap this up. I will see you guys at 2. We're going to open up the breakout room so you guys can work with one another. Ask us instructors and TAs for help. We're here to help you. Please don't be shy. Okay, we need you guys to cross this finish line. Okay, and with that, we'll go ahead and stop the lecture.